Hello, we're ready for Activity 30, Lesson 4, Composite Area. Today's learning target is I can calculate the area of composite figures. First, we have to define composite figures. A composite figure is a figure that is made up of two or more shapes, such as rectangles, triangles, or circles. A figure that is made up of two or more shapes, such as rectangles, triangles, or circles. And here's some examples of composite figures. You can see in this first one, we could draw a line there, and we would have a triangle and a rectangle, and we know how to find the area of a triangle, and we know how to find the area of a rectangle. In the second figure, there's a couple different ways you could cut this up. You could draw lines there and get three rectangles, or you could split it like this, or you could even split it like this. In the third one, I see a square right there in the middle, and then I see four matching triangles. Let's look at some examples. What is the area of this figure? So I can see there's a couple different ways I can cut this, but I choose to go straight across like that. That gives me two rectangles. Rectangle 1, rectangle 2. And I know the area of a rectangle is simply length times width. So for number 1, I see a 7 and a 5 for my length and width. So 5 times 7 is 35. And meters times meters is meters squared. For the second rectangle, I see that I have 4 times 5, which gives me 20 meters squared. Now that I've found the area of both of those rectangles, I can tell you the area of this figure by adding 35 meters squared plus 20 meters squared and getting 55 meters squared. Here's another example. Again, there's a couple different ways to cut this, but there's one way that if we cut it like this, then we only get two figures. We have a rectangle and another rectangle. So we're still using length times width. For number 1, we have 9 meters times 2 meters, which is 18 meters squared. Rectangle 2, we have 3 meters times 7 meters, which is 21 meters squared. Then we're going to add the two together. 18 meters squared plus 21 meters squared gives me 39 meters squared. Looking at the next figure, I see there's obviously a triangle there, and then there are two rectangles. So I have 1, 2, 3 figures. I know the area for a triangle is area equals 1/2 base times height. And then for the two rectangles, I'll be using length times width. We can see that the height of the triangle says 8 over there, but 8 is for this full length. So if we come up over here, that cuts it in half. It's 4 meters by 4 meters on both sides of my arrow. And then I can look right here and see if I come back down 1, I will have 5. So the height of the triangle is 5. And the base of the triangle is also 5. From here to here is 6. We can see we can come back 1 to get 5. So 1/2 5 meters times 5 meters gives me 12.5 meters squared. Figure 2, I have 6 times 2, which gives me 12 meters squared. Figure 3, I have 3 times 4, which gives me 12 meters squared. Then I just have to add those all up, and I end up with 36.5 meters squared. My next figure, again, I see that triangle, and then I have a couple of rectangles. So 1, 2, 3. Again, I'm using 1/2 base times height, and I'm using length times width. 1/2 base times height. I see my base is 8. I can see that this length is 6. This length is 4, which leaves from here to here is 2. And it shows me to go all the way up to the top is 2 more. So my height is 4. 1/2 8 times 4 gives me 16 miles squared. For my next rectangle, I have 8 times 2 because I have 6 here and then 2 more there. And I have to use this, not the 10, but the 8 times 2, which gives me 16 miles squared. Add all those together, I get 48 miles squared. Moving on to our next example, you can see I have that little circle sticking out down there. So I'll go ahead and draw that line. And then I have 2 rectangles. So I have 1, 2, 3 areas that I need to solve. The first area is area of a circle, and we know the area of a circle is pi r squared. However, when we look at this circle, it's not a full circle, it's only a quarter of a circle. So for this problem, we'll say 1/4 of a circle is pi r squared times 1/4. And then for the other 2 figures, we'll be using length times width. So for number 1, I have 3.14, which is what we use for pi. And then I have 3 for my radius squared times 1/4. So the first thing I do is I square that 3 inches, and I get 3.14 times 9 inches squared. 3 times 3 is 9. Inches times inches is inches squared. And then I'm going to go ahead and flip that. Instead of saying times 1/4, that's the same thing as dividing by 4. Multiply that out, I get 28.26 inches squared divided by 4, which gives me 7.065 inches squared. Now for the second shape, I just have 8 times 16, or 18. I have 12 there. I know the radius here is 3 plus 3 more. That's where I get the 18. 8 times 18 is 144 inches squared. And then the next shape is 4 times 5, which is 20 inches squared. Add it all together, end up with 171.065 inches squared. This last one. Again, I see a triangle. I'm going to go ahead and draw a line there, and I see part of a circle. I'm going to go ahead and draw a line there. Then with what's left, I see 3 rectangles. So I have 1, 2, 3, 4, 5. So I know that I'm going to use, for the first 3, it's length times width. For the fourth one, it's pi r squared times 1/4, because this is 1/4 of a circle. And for our triangle down here, we're using 1/2 base times height. The first rectangle, I have a 7, a 4, so 7 times 4 miles is 28 miles squared. For number 2, I know that this yellow line that I drew is 7 miles because this line over here is 7 miles. Then we have 8 more miles. So I'm going to have 5 times 15, which is 75 miles squared. For number 3, I have 3 here. Then I have this radius of the circle, which is 6. And then I have 3 more. Across the top, I have 4. So I have 4 times 12, which is 48 miles squared. Now for this quarter circle, it's got the radius of 6. So I'm going to use pi, which is 3.14, times 6 miles squared, times 1/4 because it's just a fourth of a circle. When I do 6 miles squared, I end up with 36 miles squared. Then I'm going to multiply 3.14 times 6 and divide by 4 because I know when I multiply by 1/4, it's the same as dividing by 4, and I get 28.26 miles squared. When we look at this triangle, I get 1/2 base times height. Well, it tells me right there that this is 10, but I need to figure out also what is this. So I know from here to here is 3, from here to here is 4 more, from here to here is 5, then I can backtrack these 3, and I end up with 9. So I have 1/2 9 times 10, which gives me 45. Then I can take all 5 of these figures, the area of them, and add them together and get 224.26 miles squared. That should say miles squared.